Okay, get ready for this. What if I told you the universe isn't what it seems? That the very fabric of reality might be a kind of hologram running on something like a quantum computer? Today, we are diving deep into one of the wildest ideas in all of physics, one that connects wormholes and quantum entanglement. And the craziest part? Scientists actually built a tiny version of one on a computer chip. Let's get into how they did it and what it might mean for, well, everything.
You know this image. We've all seen it in the movies, right? The wormhole. It's this incredible tunnel that just bends space-time, letting you zip from one end of the universe to the other in the blink of an eye. It's the ultimate cosmic shortcut, pure science fiction. For the longest time, that's pretty much all it was. A really cool idea.
But what if it's more than that? What if the key to understanding these things, and maybe even building one, isn't out there in space, but hidden in the strangest, most bizarre corner of quantum mechanics? This is where the story gets really, really weird.
To really wrap our heads around this, we have to start with the science, not the sci-fi. And that means we have to go all the way back to the guy who kind of started it all, Albert Einstein.
So it's 1935. Einstein and his buddy Nathan Rosen are just, playing around with the math of general relativity, and they stumble upon this bizarre solution. The equations described a bridge, a tunnel connecting two completely different places in space-time. They called it an Einstein-Rosen bridge, or ER bridge for short. This was the original scientific blueprint for a wormhole, but to them, it was just a mathematical curiosity, a fun little quirk in the theory. Or so they thought.
All right, let's put a pin in wormholes for just a second. We're going to jump from the scale of the cosmos all the way down to the quantum world. And trust me, this is where things get truly strange. We need to talk about quantum entanglement. Imagine you have two particles that are linked in this beep, mysterious way. You can separate them by a few feet, or you could put one on the opposite side of the galaxy. It doesn't matter. The instant you measure something on one particle, like its spin, you instantly know the spin of its partner. Einstein famously hated this idea. He called it spooky action at a distance because it seemed like information was traveling faster than light, which was supposed to be the universe's ultimate speed limit. Now check this out. Look at the date. The paper that introduced entanglement, the EPR paradox, was published in 1935, and the paper that introduced wormholes, the ER bridge, was also published in 1935. For almost 80 years, everybody in physics thought this was just a massive coincidence. Two totally separate, weird ideas that just happened to pop up at the same time. But then, in 2013, a couple of physicists proposed a connection so stunning it could change everything. It's this: ER equals EPR. The Einstein-Rosen bridge is the Einstein-Podolsky-Rosen's paradox. A wormhole is quantum entanglement. The geometry of space-time and the spooky connection between particles are two sides of the same coin. Just let that sink in for a minute.
So, what does this actually mean? It means that spooky action at a distance might not be so spooky after all. This idea suggests that when two particles are entangled, there's a real physical connection between them, a tiny, microscopic wormhole. The quantum weirdness we see from the outside is actually a literal bridge through spacetime on the inside.
And if you think that's a wild idea, it's really just a gateway to an even deeper, more profound concept. The idea that our entire reality might just be a projection.
This started with a weird puzzle about black holes. Physicists realized that all the information about what falls into a black hole isn't stored inside its 3D volume. It's somehow smeared across its 2D surface, the event horizon. That was a huge clue. What if our entire 3D universe, gravity and all, is actually just a complex projection, a hologram being encoded on some distant, flat, two-dimensional surface? There's this fantastic phrase from the physicist John Wheeler that just captures this perfectly. It from qubit. It is everything. You, me, the stars, space-time itself. And qubit is the basic unit of quantum information. The core idea here is that the physical world we experience actually emerges from a deeper layer of quantum information. Space-time isn't the fundamental thing, information is.
Okay, for decades, this was all just mind-bending theory. Super fun to talk about, but you had to wonder, how on earth could you ever test something like this? Well, this is where quantum computers finally enter the picture.
In 2022, a team of scientists did something incredible. They used Google's Sycamore quantum computer to create a system of qubits that behaves exactly like a traversable wormhole. Now, to be clear, they didn't open a portal in their lab. They built its quantum equivalent, a simulation so good that it follows the same fundamental rule. And their mission was actually pretty straightforward. Could they take one qubit of information, feed it into one side of their quantum system, and have it pop out the other side completely intact, as if it had traveled through a shortcut in space-time?
But there was a big problem. Theory says that any normal wormhole would just collapse the second you try to send something through. To get around this, you'd need to prop it open with a pulse of something called negative energy. Think of it like this. Regular energy pulls space-time inward. That's gravity. Negative energy would do the opposite. It would push space-time outward, basically holding the walls of the wormhole open just long enough for something to sneak through.
So here's how the experiment worked, and this part is just amazing. The information from the qubit goes into the system, and it gets totally scrambled across all the other qubits. Imagine dropping a speck of ink into a glass of water and watching it spread out into a chaotic mess. Then, they hit the system with that negative energy pulse. And incredibly, the chaos runs backwards. It's like watching the ink drop magically pull itself back together into a perfect little speck. The original information emerges, totally unscrambled, on the other side.
And it worked. It actually worked. They ran the experiment with both positive and negative energy pulses, and they saw the exact telltale signature that information had successfully passed through a wormhole. They had opened a portal on a chip and sent a message through it.
This is just a massive achievement. But I know what you're thinking. Why? Why go to all this trouble? Are we going to be building starships with this stuff anytime soon?
Yeah, the short answer is no. This research isn't really about interstellar travel. It's about something way more fundamental. This is a new tool, a new way to try and figure out the deepest mysteries in physics. It's about finally building a bridge between Einstein's gravity and the quantum world, the two great theories that describe our universe but just don't play nicely together. This is about trying to read the source code of reality itself.
And yes, of course, this stuff brushes up against time travel. The famous Stephen Hawking had an idea called the chronology protection conjecture, basically that the laws of physics are rigged to prevent time travel paradoxes. And this research actually supports that. It seems the very same quantum effects that you need to prop the wormhole open would also slam it shut if you tried to use it to, say, go back and create a paradox. It's like the universe has its own failsafe.
So we're left with this final, absolutely staggering thought. For the first time, we have real experimental evidence for an idea that sounds like it came straight out of a movie. That the solid 3D space we live in is literally woven from the ghostly connections of quantum entanglement. That reality is a hologram and its code is written in qubits. It really makes you wonder, what is our universe really?